I'd like to begin this lesson by defining a rational expression and what we mean by reducing a rational expression to lowest terms. In arithmetic, we know that any number that can be written as a fraction with an integer for the numerator and an integer for the denominator is called a rational number. A similar definition exists in algebra for a rational expression. Let's look at that definition. Any expression that can be written as the quotient of two polynomials where the denominator is not equal to 0 is called a rational expression. Remember that quotient means divide, and for a polynomial, we mean an expression with a finite number of terms, and the powers of the variables must be whole numbers. Let's look at some rational expressions. We have x minus 3 in the numerator over x plus 1 in the denominator. We could have x squared minus 5 in a numerator over x squared plus 4x minus 5 in the denominator. And the expression x squared plus 3x plus 2 is a rational expression because we could write that in the numerator of a fraction over a denominator of 1. In arithmetic, a simplified fraction is commonly called a fraction reduced to its lowest terms. Let's look at what we mean by a fraction reduced to its lowest terms. A fraction reduced to lowest terms is a fraction in which the only common factor of both the numerator and denominator is 1. I'd like to begin by reviewing how we reduce fractions in arithmetic. Let's look at this next problem. Reduced to lowest terms, we have the fraction 18/12. Now, there are a couple of ways we can do this. We could think that 18 and 12 have a common factor of 6, and we may divide the numerator by 6 and the denominator by 6. 18 divided by 6 is 3, and 12 divided by 6 is 2. 18/12 reduces to 3/2, and the only common factors for this numerator and denominator, the only common factor would be 1, so it's reduced to lowest terms. Another way to work the very same problem would be to think that 18 factors as 6 times 3, 12 factors as 6 times 2. We may rewrite this as 6 times 3/2 using the multiplication property of fractions. We know that 6 is 1, so this would be 1 times 3/2 or 3/2. Now, I expect that some of you divide by the common factor, and some of you write 18 and 12 out as factors and work the problem this way. Elaborating on the second way, I could take the 18 and say that it's 6 times 3 over the 12, which is 6 times 2. Since there's a common factor of 6 in the numerator and denominator, I could divide out the common factor, thinking 6 goes into 6 once, 6 goes into 6 once. I'm left with 1 times 3 over 1 times 2. Dividing out the common factor is really a shortcut way of reducing fractions. Now let's look at the reduction property of fractions. if I have a times x in the numerator, a factor of a times a factor of x, over a times y in the denominator, a factor of a times a factor of y in the denominator. The reduction property of fractions says that I can divide out the common factor a, and the resulting fraction is x over y. It's very important that we realize that a times x over a times y is equal to x over y. Of course, a does not equal to 0 and y does not equal to 0. You must realize that the reduction property of fractions says that we may divide out common factors, not common terms. We may divide out common factors and the resulting fraction is equal to the fraction that we started with. Now let's use this property to reduce some algebraic fractions. If I have 18xy over 12xz, let's write the 18 as 6 times 3 times the x times the y. In the denominator, let's write the 12 as 6 times 2 times x times z. Let's divide out common factors. The 6's divide out, the x's divide out. We're left with 3 times y in the numerator and 2 times z in the denominator. Now, of course, x does not equal to 0, z does not equal to 0. That is a restriction that in general we do not write out every time. It's just understood that the denominator does not equal to 0. For the next problem, it's fairly similar. It's just that our factors have exponents other than the exponent 1. Well, we can work it this same way. Let's factor the 18 as 6 times 3. The x cubed means x times x times x, and then we'll have times the factor of y. In the denominator, the 12 is 6 times 2 times the x, and the y squared factors as y times y. Let's divide out common factors. We'll divide out the 6's. We can divide out 1x in the numerator and 1x in the denominator. We can divide out 1y in the numerator and 1y in the denominator. We're left in the numerator with 3 times x, which is 3x squared. In the denominator, we're left with 2 times y. Since the only common factor of the numerator and denominator is 1, this fraction is reduced to lowest terms. Now we know a shorter way to reduce this fraction than to write out all the factors, don't we? We could use our exponent laws. Let's work this problem again and let's use our exponent laws. Usually on my coefficients 18 and 12, rather than writing them out as factors, I go ahead and divide that 6 out by saying 6 goes into 18 3 times, 6 goes into 12 twice. Let's write the 3, let's write the 2. Since I have a factor of x cubed in the numerator and a factor of x in the denominator, I know I have more factors of x in the numerator, so my factor of x stays in the numerator, and using my exponent laws for dividing like bases, I can say that my power will be the 3 subtract the power of my x factor in the denominator, which is 1. For my y's, since I have more factors of y in the denominator than I do in the numerator, I know that my y factor stays in the denominator, and using my exponent laws, I can take the power of the y in the denominator and subtract from it the power of the y in the numerator. My result is 3x to the second power over 2 y to the 2 subtract 1 will give me first power, and I don't need to write the 1. Notice I get the same result. This method was much shorter, wasn't it? When we're reducing rational expressions, we'll use the reduction property of fractions, but we can also use our exponent laws when we have like bases raised to the powers greater than 1. Let's work some more problems. For problem number 1, let's divide by our common factors for our coefficients, and let's use our exponent laws for our variable factors. We have a common factor of 4. 4 goes into 8 twice and into 12 3 times. So let's write our 2 and our 3. For our x cubed over x, since I have more factors of x in the numerator, my x will stay in the numerator. Using my exponent laws, I know I'll have 3 subtract 1 for the power. For my y's, I have more factors of y in the denominator. Using my exponent laws, I'll say 3 subtract the 1, getting the 1 as the power of my y in the numerator. For my z's, I have more factors of z in the denominator, so my z stays in my denominator. Using my exponent laws, my power will be 8 subtract 4. So I'll have 2x to the 3 subtract 1 would be second power over 3 y to the second power z to the fourth power. And that is reduced to lowest terms. Look at problem number 2. In my numerator, I have 2 terms. I have a binomial. In my denominator, I have 2 terms. I have a binomial. It is very important that we remember that the reduction property of fractions says that we may divide out common factors, not common terms. So to reduce fractions that have more than one term in the numerator or denominator, we first need to factor the numerator and denominator and then divide by common factors. Let's look at this problem. Factoring my numerator, I have a common factor. Let's factor 5x squared y. When I factor 5x squared y out of the first term, I'm left with x plus, when I factor it out of the second term, I'm left with 1. Factoring my denominator, I have a common factor of 10xy cubed. When I factor 10xy cubed out of the first term in the denominator, I'm left with x, and out of the second term, I'm left with plus 1. Now let's look. My numerator has a factor of 5, a factor of x squared, a factor of y, and a binomial factor of x plus 1. My denominator has a factor of 10, a factor of x, a factor of y cubed, and a binomial factor of x plus 1. For my coefficients, 5 goes into 5 once and 5 goes into 10 twice. Let's go ahead and write that 2 in the denominator. I don't think I'm going to need the 1 in the numerator. Let's also go ahead and divide out the common factor x plus 1 over x plus 1. We know that that is equal to 1, and we can divide that out. On my x squared over x, let's use my exponent laws. My x will stay in the numerator. The power will be 2 subtract 1. For my y divided by y cubed, my y stays in the denominator. My power will be 3 subtract 1. So I will have x to the first power in the numerator. In the denominator, I'll have 2y to the second power. And that is reduced to lowest terms. Now, I want us to look at problem number 3. And when you first look at problem number 3, you will notice that there are no common factors for the numerator and denominator. But the numerator and denominator have a special relationship. Let's look at that and see if you know what the relationship is. We are to reduce to lowest terms. We have 4x subtract 3y over 3y subtract 4x. Now, when we try to factor the numerator and denominator, they don't factor. But notice the relationship. They are opposites, aren't they? The 4x in the numerator is understood to have a positive sign in front of it. The 4x in the denominator has a subtraction sign in front of it. The 3y in the numerator has a subtraction sign in front of it. The 3y in the denominator is understood to have a positive sign in front of it. These expressions are called opposites. The numerator is the opposite of the denominator. Anytime we have factors in the numerator and the denominator that are opposites, what we do is to factor a negative 1 out of either the factor in the numerator or the denominator. Let's factor a negative 1 out of the terms in the numerator. When I factor negative 1 out of 4x, I'm left with negative 4x. And when I factor negative 1 out of negative 3y, I'm left with positive 3y. Remember, when we factor a negative 1 out of a term, it changes its sign. As you can see, that happened with the 4x, and that happened with the 3y. Now, let's just rewrite the denominator as 3y subtract 4x. Now, in the numerator, I have a factor of negative 1, and for my binomial factor, I want to change the order of the terms using the commutative property. Let's write the 3y first, and then the minus 4x. And now notice, I have a negative 1 factor times 3y minus 4x in the numerator, and in the denominator, I have a factor of 3y minus 4x. Dividing out common factors, 3y minus 4x is common to both the numerator and the denominator. What is the result? Well, the result is negative 1, isn't it? Remember that 3y minus 4x over 3y minus 4x equals 1. That's why we can divide out common factors and have an equivalent resulting fraction. So basically, this means negative 1 times 1, which is negative 1. Look at problem 4. I have a binomial in the numerator and a trinomial in the denominator. Well, I know that I need to factor the numerator and denominator and then divide out common factors. The common factor of the numerator is x. So let's factor the x out. We're left with 5x in the first term plus 1 in the second term. In the denominator, we have a common factor of x. In the first term, we're left with 5x squared. In the second term, subtract 4x. In the third term, subtract 1. Now, in my numerator, I have a factor of x and a factor of 5x plus 1. In my denominator, I have a factor of x, and then let's see if I can factor this trinomial. Let's use 5x times x to give me 5x squared. For the minus 1, let's use 1 times 1. And I believe this one needs to be positive and that one needs to be negative. Let's check that. 5x squared minus 5x plus 1x gives me the minus 4x. 1 times negative 1 gives me a negative 1. Dividing out common factors, I may divide out my x's. I may divide out my 5x plus 1s. I am left with x minus 1 in the denominator. And what am I left with in the numerator? It's understood to be a 1, isn't it? For problem number 5, once again, let's factor. We can factor the numerator, x plus 3 times x minus 2. Let's factor the denominator. It's the difference of squares. X plus 2 times x minus 2. Let's divide out common factors. We're left with x plus 3 in the numerator and x plus 2 in the denominator. Now, is this reduced to lowest terms? Are there any more common factors? The only common factor for this numerator and denominator is 1, so it is reduced to lowest terms. Do not be tempted to divide out the x's. The x's are terms, and we may not divide out terms. We may only divide out common factors. For problem number 6, let's factor. The numerator is a perfect square trinomial, isn't it? It factors as 2x plus 3 times 2x plus 3. Now you may want to write this as 2x plus 3 squared. However, usually when I'm reducing rational expressions, I would prefer to write it as two separate factors instead of writing it as the 2x plus 3 squared. That's actually your call. Let's factor this denominator. On this 15, let's use 5 times 3. And let's see, I want opposite signs. I believe that 5 needs to be minus and the 3 needs to be positive. Now, dividing out common factors, I am left with 2x plus 3 in the numerator, x minus 5 in the denominator. The only common factor of the numerator and denominator would be 1. So this is reduced to lowest terms. For problem number 7, I have a trinomial, but let's take out the common factor 4. That will leave us with x squared minus x minus 12. In the denominator, let's take out a common factor of 2. That will leave us with 16 minus x squared. Now, let's see here. Let's go ahead and divide out common factors for the 4 and the 2, but we can factor the trinomial in the numerator and the binomial in the denominator a little more, can't we? Let's say 2 will go into 4 twice and 2 will go into 2 once. Let's go ahead and write the 2, and then let's factor the x squared minus x minus 12. let's use a -4 and a +3. For 16 minus x squared, I'm not going to write the coefficient of 1. I don't need it in this case, do I? That's the difference of squares. It factors as 4 plus x times 4 minus x. Now, I don't have common factors, but I do have a factor in the numerator that is the opposite of a factor in the denominator, don't I? Now, remember that any time I have factors that are opposites, I factor a -1 out of either the factor in the numerator or the denominator. I'm going to choose to factor the -1 out of this denominator factor, so let's write this numerator. I'm going to go ahead and write this 4 plus x factor as x plus 4. I may do that using the commutative property. And for the 4 minus x, I'm going to factor a -1 out of each of those terms. And that -1 is a factor, so I'm going to enclose it in parentheses. When I factor -1 out of 4, I'm left with a -4. When I factor -1 out of -x, I'm left with a positive x. Now let's rewrite this. I'll have 2, I'll have x minus 4, x plus 3. Let's write this -1 factor first. Let's write the x plus 4. And then when we get ready to write the -4 plus x, let's once again use the commutative property. Usually we like the variable first, especially if the variable is positive. So let's write the x first, then the -4. And now what can I do? I have a common factor in the numerator and denominator, x minus 4. So let's divide those common factors out. The other thing I'm going to do is I have a -1 in the denominator. Of course, I could write that negative a lot of different ways, but usually the most common thing is to bring the negative out in front of the fraction. So I'm going to write the negative out in front of the fraction. Then let's write the factor 2 and the factor x plus 3 in the numerator. And then in the denominator, let's write the x plus 4. Let's look at problem number 8. In problem number 8, we have 4 terms in the denominator. Do you remember how we factor when we have 4 terms? We have x cubed minus 1, which we recognize as the difference of cubes. We know it factors into a short factor and a long factor. For the short factor, we'll have x minus 1. For the long factor, we'll have x squared plus x plus 1. Now, for this denominator with 4 terms, we group, don't we? Let's group these and these. For these first 2 terms, let's take out a common factor of x squared. That will leave us with x minus 1. And for the second 2 terms, let's take out a common factor of minus 3. That will leave us with x minus 1. Now I want you to be careful here. My numerator consists of 2 factors, x minus 1 and x squared plus x plus 1. My denominator still consists of 2 terms. X squared times x minus 1 is my first term, and then I have my subtraction sign. And remember that addition and subtraction signs separate terms. So this is a term, and then I have my second term, 3 times x minus 1. I cannot divide out common factors until both my numerator and denominator are in factored form. So let's rewrite this numerator as it is in its factored form, and let's complete the factoring of the denominator. For my two terms, I'll look for the common factor. I have a common factor of x minus 1 in each of these terms, so I'll write my common factor x minus 1, and then in my second factor, I write what's left. For my first term, when I factor out x minus 1, I'm left with x squared. Then I have a minus sign. And when I factor x minus 1 out of my second term, I'm left with the 3. Now notice my denominator is now in factored form. I have a factor of x minus 1 and a factor of x squared minus 3. Using my reduction property of fractions, I can divide out the common factor, x minus 1. That leaves me with x squared plus x plus 1 in the numerator, which is a prime polynomial, and x squared minus 3 in the denominator, which is a prime polynomial. Now I'd like for you to work problems 9 and 10. I'll put them on the screen. Please copy them, work them, pause your tape while you work them. Then I will work them. Here they are. How did you do? Let's work these problems. For problem number 9, let's factor our numerator. Let's factor our denominator. Since our numerator and denominator are in factored form, let's divide out our common factors, and our result is 3x minus 1 over x plus 1. For problem number 10, let's factor a common factor out of the numerator. Our common factor is 6x squared. When we do that, we're left with x minus y. In the denominator, let's factor out 3xy. When we do that, we're left with y minus x. Now let's see what we can do. Let's go ahead and divide out the common factor 3. 3 goes into 6 twice and into 3 once. So let's write the 2. We have common factors of x squared over x. Let's use our exponent laws for x squared over x. X will stay in the numerator. The power will be 2, subtract 1, so that will be the first power, and we don't need to write that power, do we? We have a factor of y, and what about these two binomial factors? They're opposites, aren't they? Well, I think for a change, if you'll remember when I first told you about opposites, I said that we could factor a negative 1 out of either the numerator factor or denominator factor. Let's factor it out of this numerator factor. Let's write that factor of negative 1. When I factor negative 1 out of x, I'm left with negative x. When I factor it out of negative y, I'm left with a positive y. And then, of course, in the denominator, I have y minus x. Now, for this numerator, 2 times negative 1 is negative 2. have a factor of x, and let's reorder the terms in the binomial factor. Let's write the y, then the minus x. In the denominator, we have the y times the y minus x. Dividing out common factors, we're left with negative 2x over y. Let's bring the negative in front of the fraction. Let's write the numerator as 2x and the denominator as y. That completes the Reducing Rational Expressions to Lowest Terms lesson. Please rewind the tape before you return it so it will be ready for the next student. Thank you.